Okay, here we go.
Okay.
Okay.
Okay, so you guys get me for 2 more lessons, and then I gotta work with the 30s for a bit. So, okay, so pretty much I should be able to at least teach you guys, though, all of the lessons in this unit minus 1. Okay? And even though I'm going to work with the 30s starting Wednesday, Thursday, still come get help from me, okay? So, the plan for you guys the rest of this week then is I'm going to try to do a lesson today while the 30s are working, a lesson tomorrow while they're writing a test. And then after that, then when Kwan comes back, he's going to work with you guys in the rest of the unit. Okay? So, we've now covered one type of function, quadratics. And you previously learned about linears. I have to now, in the next 3 lessons, show you 3 new types of functions. Today, we're going to learn how to do an absolute value function. Tomorrow, we're going to learn how to do a reciprocal function. And Kwan will teach you guys about how to do inequality functions. That make sense? And each one of them really only requires 1 lesson, because most of the skills that you've already learned, we keep applying them. Okay, like, a lot of the things don't change. We still find x-intercepts. We still find y-intercepts. It's just I'm going to show you a new type of graph. So let's start today. Absolute value is a new type of equation. Here's basically the concept. The number is always positive. Okay? So let me give you an example here. Let's say that I gave you a function like this. I asked you to find the absolute value of 8. These lines right here, like long lines, are what absolute value symbols are. The way this works is that the absolute value of 8 is 8. Kids dumb. A lot of kids, the first question they ask is, why does this matter? Give me a sec, I'll show you. But if I were to ask you the absolute value of -7, the answer now is just 7. Let me give you an example. When you guys take physics with me, there are a lot of examples in physics where negatives don't really apply. For example, magnetic force. Okay. If I were to ask you how much force a magnet has, we don't ever use a negative number. We wouldn't say that a magnet has negative magnetic attraction. We would never say that a mass is negative. Does that make sense? In temperature, in chemistry, you guys know how we talk about kelvins? It's not really logical to have negative kelvins. And so there are some scenarios in physics and chemistry where even if you get a negative number, we don't want to consider it a negative number. Does that make sense? Electrostatic forces are another thing where when we get there, I'll show you. But a lot of our formulas, like for example, 1 is that the electric force is equal to K times Q over R squared. That's a formula we use in physics. You'll see an absolute value on it because it basically says the direction doesn't matter. It's always going to be positive. Does that make sense? Do you guys know the difference between vector and scalar? Have you heard that in science before?
Yeah.
What's a vector? Maybe you haven't learned this. I'm not sure. That's why I was checking. Okay, a vector has a unit and a direction. A scalar only has a unit. Okay, let's just, whatever. I'm going off topic today. Oh, I hate it when it does this. Okay, here's the Earth. I'm not the world's greatest drawer, but here's the Earth. You guys have heard of gravity before, right? G. What's the number for gravity in physics? Do you guys remember? 9.81. Is it negative 9.81?
No.
Should it be negative 9.81? Gravity. It's falling down, isn't it? No. Is that the 10 space?
Yeah, that's it. And then, so switch here. And then this one. If I include the button, unless you like to include it.
Oh, don't worry about it. I'll take care of these. Okay. Sometimes you guys have heard that gravity is negative 9.81. And in certain instances, it is because things fall down. But it really depends on your perspective. If I am standing right here on Earth and I drop an object, it's going that way. However, what if someone in Australia drops an object? Which way is it going? Well, it's going... Is it going up, though? Well, that doesn't make sense, right? Because as I've made my drawing here, this item fell that way, but this item fell this way. Is it fair to say that this is down and then this is up. A person in Australia doesn't have an object fall up. Does that make sense? And so there's a certain scenario where sometimes what we would do is we would find the absolute value, meaning that like even if you wanted to use a negative, well, let's just ignore the negatives here and let's just always use a positive number. Can you guys kind of see how this might have applications? Mm-hmm. One more example. Let's say that I wanted you to guess a value, like to pick the number between 1 and 100. Okay. Let's say that in my head I had the number 51, and then somebody guessed 53, and somebody else guessed 49. Who was closer? They were tied because this guy was plus by 2 and this guy was minus 2. But would anybody say that this guy wins because he's positive 2? Well, no, I think you guys intuitively know that what really matters in this case is that the difference between these numbers is 2. Whether it's negative 2 or whether it's positive 2, the absolute value of both of these numbers is they were both off by 2. You get what I'm saying here? So, anyways, that's the point behind absolute value. It's the easiest function I know of. Here's how it works. If the number is positive, it's still positive. If the number is negative, then it's positive. Does that make sense?
Okay.
And the way we represent it is using these symbols right here, long lines. It's super easy. So here's some more examples here. If I give you the absolute value of 5, it's 5. If I give you the absolute value of negative 5, it's 5. If I give you the absolute value of 0, by the way, it's still 0. 0 is neither positive nor negative. Here's the point I need to make, though. Stay with me here. Here's how this function works, then. It's kind of an if-then statement. If it's positive, do nothing. If the number was already positive, do nothing. But if it was negative, how do you make it positive? Like, if it's negative, you need to make it positive. And one of the ways that you can make a number positive is by applying a double negative. Think of it like this. The absolute value of negative 5, what you're really doing is you're taking an extra negative to that negative 5 to then make it positive. So basically the way it works is if it's positive, do nothing. If it's negative, add an extra negative. Negative times negative now is positive. Does that make sense? That's really what an absolute value function needs to do. If it's negative, put an extra negative in front, and that makes it positive for you. So we'll try some more examples. What's the absolute value of 3? 3. Absolute value of negative 7. Absolute value of negative 12. Okay, now let's ratchet it a little bit harder. Obviously, that's not just as hard as it gets. But I always start really basic, right? How about this one here? Well, think of the absolute value as a set of brackets. What I'm really asking you to do here is 2 minus 7, which normally would be minus 5, right? But this absolute value thing right here means that although this would be minus 5, now we're going to make it plus 5. So what we're really being asked to do is 5 minus 3 times plus 5. Minus 3 times 5 is minus 15, which means the answer is negative 10. Now this throws some kids at first, because they're like, hang on, Chris, you just said you can't have negative numbers. Well, only this part right here can't be a negative number. The rest of the math can still get you a negative number, but only this little bit right here won't be negative. So rather than it being 2 minus 7 to give you minus 5, this bit now became plus 5. Does that make sense? So I know the final answer is negative, but that's okay, so long as just this portion right here was turned into a positive. Should I show that one more time? 5 minus 3, absolute value 2 minus 7. 2 minus 7 is negative 5. But the way an absolute value works is if it's negative, just make it positive. So I know this was negative 5. As a way of removing these big brackets here, just change the negative to positive. This will now be 15, and there's your minus 10. Does that make sense? Okay, let's try this one. minus 2, bracket 5 minus 7, all squared plus 6, and then all of that is absolute value. So start kind of in the middle with your dead mass. What is 5 minus 7? Minus 2. That number then has to get squared. So that would give you positive 4. Then minus 2 times by 4 would give you minus 8. So all that's minus 8. You'd add 6. So you'd have minus 2. But do you see how all of this is now absolute valued? So although it was supposed to give you minus 2, the final answer is and we can keep building. This next one here looks trippy, right? Because there's absolute value signs everywhere. So just approach them one at a time. Right here, here and here, I see an absolute value sign around a negative 4. So just don't call it negative 4, call this positive 4. And right here and here, I see an absolute value sign around a negative 3. Just call it a positive 3. Okay, well then 4 minus 3 is 1. Do I need to actually do anything to the 1 though? It's already positive, so my answer is 1. A lot of kids look at this though and they say minus 4 minus minus 3, and like, but that's not how it works. You have to individually, every time you see an absolute value, just change it to the positive number. Here's where things get challenging. What if I give you x? Because we need to get to the point of doing algebra, right? Well, what is x? X could be anything. Really, there's two possibilities here. X could be positive. Like, for example, let's say x was 7. Well, if x was 7, would you have to do anything to that value? Now, if x was positive, you would do nothing to it. So that means it would equal x. This is the one that usually loses kids. But what if x was negative? X could be negative. What do you do if it's a negative number? You make it positive. But how do you make it positive? By adding an extra negative. So if x was negative, add an extra negative. Here's where this gets weird then. That's your answer. The absolute value of x is x, and it's also negative x. This is the one that blows kids' minds.
All Blackfoot 7-8 students, please go to Madame Doyle's class for class today. That's all Blackfoot 7 and 8 students. Please go to Madame Doyle's classroom for your class today.
Let me try an example here. Let's say that x was negative 3. Hypothetically, let's say this was negative 3. See how, because it's a negative right here, we know that this would turn into positive 3, right? Because we know that's what absolute values do, right? An absolute value just removes the negative sign. But how does it go about doing that? Well, it does it by adding an extra negative sign. And so if I have a negative sign right here, and then if x itself was negative 3, can you guys see how the negative that came right here goes here, and then because it was negative 3, double negative then makes it positive 3? It's very trippy then, because you actually have two answers. Absolute value of x is both x and negative x. Let me show you another one here. This guy right here, there's actually two answers. One of the answers is x plus 1, and the other answer is negative x plus 1. You follow that idea? Say that this was positive. Hypothetically, this is positive. If it was positive, do nothing to it. Say that this was negative. You want to make it positive. How do you make it positive? Add an extra negative. That extra negative would then take the negative and make it positive, which is why this thing right here has an extra negative in front. You could, by the way, make this negative x minus 1. So what ends up happening now is you actually get two answers.
Blackfoot 7-8 students, please go to Madame Doyle's class for your class today. Blackfoot 7-8, please go to Madame Doyle's for your class today.
I made sure to teach this section here after quadratics because hopefully it's not brand new concept to you that you can have two answers. Because we've been working with that for a while, the idea that you can have more than one answer. Only what ends up happening here is that this implies that you have more than one equation. That's all. So it actually isn't as hard as it seems. If you can wrap your head around the logic, that's great. But in terms of solving things, it's actually not as challenging as you think. Let me show you an example. I'd like for you guys to solve this. And to do it at first, I'm actually just going to look at it and tell you the answers. I'm not even going to do algebra. I'm just going to look. I need some number that when I minus 3, it gives me 7. 10 should be, right? 10 minus 3 would give me 7. And then it's already positive. We're golden. Does that make sense? But there's more than one answer that would work. Can anyone pick out the other answer that would work? -4 is right. Why? Talk it through. -4 would minus 3. It would give you -7. But then -7 would become 7. Do you guys see how we'd have two answers here? Just like in quadratics. The question now is though, okay, I can see that maybe. How do I algebraically solve? So let me show you how to algebra this instead. What you just do is you just do it twice. What you do here is you go x minus 3 is 7, add 3 to both sides, x is 10. Literally just remove the absolute value signs and just solve. But what if it was a negative number that then became positive? Well, here's how you solve that problem. So I've done it once now. Now make it negative x minus 3 equals 7. Remember how I told you that this could be equal to this? Or the same thing with a negative sign in front? Well, now to solve that. Now, one of the easiest ways I find to deal with this, it is very possible for you to distribute the negative. I actually have a better trick. Just try it like this. Bring this negative to that side over there instead. I find that for a lot of kids this makes sense because this bit right here, if this was equal to -7, then when you absolute value the -7, wouldn't it give you +7? Well, now it's not bad. Just add 3 to both sides and hey look, I got the other answer just like we thought. So absolute values, once you wrap your head around what's happening, the biggest trick is just do it once, no specialties to it. Do it again, but just throw a negative sign in front. And always check your work. So let's try another one. Let's try this one here. The first time you solve it, literally just ignore the absolute value signs. Go 6 minus x equals 2. Minus 6 from both sides. Minus x is -4. Okay, x is 4. Are we okay following that? Check your work. 6 minus 4 would be 2. 2 is 2, yeah. That one's the easy one. Well, the next time you do it, all you got to do is remove the absolute value signs, but put a negative in front instead. So make it negative 6 minus x equals 2. And just solve this. Now you can distribute the negative. My personal favorite, though, is throw the negative on the other side. So make it 6 minus x equals -2. And like, do you guys get what I'm saying, by the way, when I say throw the negative on the other side? Does that make sense, everybody? And then minus 6 from both sides. Minus x is -8. So that means x should be 8. Check your work. 6 minus 8 would give you -2, but then it becomes 2. What am I doing so far? Any questions? So let's put it with a quadratic. Yay! Okay, a lot of kids, they get freaked out because they're like, these absolute values. But the work is not harder. You just have to do double the work. That's all. You literally have to do everything twice. You have to do the positive case, just normally, and then you have to do the negative case with an extra negative sign. That's it. So let's try it. The first time, I'm just going to treat it exactly as though there was no absolute value sign. I'm just going to solve it. How do you solve a quadratic? Make it equal to? Okay. Let's follow that. Check your work. 3 squared is 9. Minus 3 times 3 is 9. 9 minus 9? 0. Why didn't it work? You guys can catch my mistake. It's actually 2. Okay, but actually I wanted to lead into a point here. You should always check your work. Here's where you're not going to like things though. There are actually extraneous answers though. You should always check your work, not just to make sure that you didn't make a mistake, because I made a very simple mistake there, but it is actually possible to have an extraneous answer. I'll show you when we come across one. Let me keep checking this work here. That should have been a 2. Nobody stopped me. Okay, if I do 2 squared, that gives you 4. 3 times 2 would give you 6. 4 minus 6 would give you minus 2, which would then become 2. So this one works. What about negative 1? Negative 1 squared will give you plus 1. Then 3 times... Hang on a sec here. I still didn't do this right, did I? Yeah, hang on a sec here. I still didn't do it right. Shoot. Can you actually factor this? Shoot. There's a mistake on this. Can you guys make this a minus 2? Okay, I can't get mad at you because I screwed up, I guess. Shoot, make that a minus 2, so this is a plus 2. And then now it'll work. Shoot. Now I really screwed things up. I thought I was being clever. Okay, make that a minus 2. Make that a minus 2. Make that a plus 2. Make that a minus 2. There we go. A minus 1. Which makes that a plus 1. Okay, now I'm going to try it one more time here. 1 squared would give you 1. Minus 3 times 1 would give you minus 2. Here's where I finally got an extraneous answer. When you absolute value that minus 2, it would actually give you regular 2. But I want it to equal minus 2 now. Can you guys see how you can get an extraneous answer? There could be an error in these ones here. The point behind the slide, I buggered this up so badly, is always check your work. Because those extraneous answers still exist. Sorry. Oh, I screwed that one up. Let's try another one. Let's try this one here. Okay. To solve it, just treat it like normal. I didn't even do the other case on the other one because I screwed up so badly. Just treat it like normal. X squared plus 4x equals x squared minus 6x minus 3. Okay, now solve. How do you solve a quadratic? Actually, it's not even quadratic. Why isn't it quadratic? Okay, the x squareds cancel. Add 6x to both sides. So you'll have 10x equals minus 3. I believe I found an answer of this. That makes sense? Okay, let's check it. Okay, I didn't intentionally make any mistakes this time, so I'm not trying to fool you. Negative 3 over 10 squared plus 4 negative 3 over 10 gives me negative 1.11. This side right here is negative 1.11 when I plug negative 3 over 10 in. So far so good. Now let's try the other side. I'm going to plug in negative 3 over 10 squared minus 6 negative 3 over 10 minus 3. I'm going to get negative 1.11. Except, see how this side right here was supposed to be absolute value? It didn't. Which means that it actually should become positive. This doesn't actually work then. Do you guys get what I'm saying here? This side over here was a negative. I don't care what this number right here is. By definition, an absolute value should always give you a positive number. So even though the inside bit gave me a negative number, the outside should make it positive. These two things that are not equivalent to each other. And so, therefore, this was actually extraneous. Which is a pain in the butt, because you got to check these every single time. Does that make sense? I think I did a better job of this one than the previous example, because last one I screwed up on so bad. Okay, well you might think, well maybe there's no answers. But here's what we've missed. We've only done one of the two cases. What if we tried the other version? What if I did the one where I put a negative sign on things? So let me show you how that would look. What if we did x squared plus 4x, but we made it equal to negative x squared minus 6x minus 3. And we flip all of this stuff right here with that extra negative sign. Let's try solving this and see whether we get some answers that could work. So, my personal preference, though, the easiest way to get rid of this negative sign to me is not to actually distribute it, but bring it to the other side. I actually like to make it negative x squared minus 4x, and then I can leave these guys in the same spot that they were. That's my personal preference. Okay, let me try this again without screwing up. I'm going to add x squared to both sides. I'm going to add 4x to both sides, which is going to give me 2x squared minus 2x minus 3.
Randy, next question.
This isn't going to factor, is it? I don't think so. Let's use the quadratic formula. It's going to be negative 2 plus or minus 2 squared minus 4, 2 minus 3, all over 2 times 2. What is that? 4 plus 24, root 28. You get 28 too?
No, I just got lazy.
Okay, we should reduce this. You guys remember how to reduce these? 28 is actually 4 and 7. Why did I pick 4 and 7 though? Because you can square root the 4. So you can write it as 2 plus or minus 2 root 7 over 4. And then you can reduce it to 1 plus or minus 1 root 7 over 2. Okay, let's try it. Here's what I'm going to do my calculator. I'm going to go 1 plus root 7. Then I'm going to divide by 2. And then this number right here, I'm going to store it as a. Have I shown you guys this trick before? Store as a letter. If you haven't seen this before, ask me later. I'll show you how. Some calculations you can just literally go back up and find the number. You can do that too. Now I'm going to try testing it. I need to take a, oh goodness, where is it? A squared and add 4a. This side over here is now 10.61. That make sense? This side over here, if it's 10.61 or negative 10.61, we're good. So I'll try a squared minus 6a minus 3. And it was negative 10.61. But I still have to absolute value that negative 10.61. So when you do absolute value it, it works. That makes sense what I'm saying here? In theory, I should try the other answer. So I should also do 1 minus root 7. And then divide by 2. I'll store that one as b. Try the same thing. So you're not going to like absolute values. I won't make you do them a ton. because it's more work. That's really what people don't like about it, is it's tedious because you have to do more stuff. I wouldn't say that it's harder stuff, hopefully. It just means you have to do a lot of it. So this is what I got with the negative version one. I'm actually not even going to test it. Can you guys explain to me why I shouldn't even bother testing? I know that it's extraneous. Yeah. How in the world am I going to take any number right here and absolute value it and get a negative? You can't, right? That literally defies it. So although there were 3 answers that I got, one of them was negative 10 over 3. That was extraneous. One of them is the negative version of this. That was also extraneous. There is only one answer. It is 1 plus root 7 over 2. The negative half of the 2 answers, that one didn't work. So it's not harder work, it's more work, and you always have to check, which is a pain in the butt. You guys have any questions so far? Okay. If you feel like you have the idea behind what an absolute value is, then here's actually the point of my lesson. All of that was just kind of the preamble. I need you to know what an absolute value graph looks like. Okay, that's our goal. Here's what an absolute value graph looks like. These are actually quite useful. I'll show you some other applications of them. If you want to graph it, go to y equals. And then to get the absolute value signs, I found the fastest way is to go second, 0. This is called the catalog, and it literally has every single thing your calculator can do. But the cool thing is absolute value is alphabetically first. See ABS right there? Press enter. Now, if you have a new school calculator, it will actually bring up 2 lines, which is really cool. If you have an old school calculator like mine, it brings open a bracket. So you have to like write in X and close the bracket. Okay. If not, just type in X. Now let's talk about what the graph looks like. So I'm going to zoom 6. This is what the absolute value of X looks like. It looks like a V. Let's talk about Y. If you had negative Y values, they're going to become positive. This graph currently looks like this. But here's what happened. The graph was supposed to go down here into the negatives. And every single time that you would have had a negative value, it just popped it right back up to being positive. Does that make sense? So it makes a nice V. And there's a lot of real-world applications for this. For example, pool. This is one that's near and dear to me because I'm trying to learn how to play pool. If you're trying to make a bank shot in pool, what you're really doing is you're simulating an absolute value function. When you try to make a pool shot, and I can tell you this from experience, what you're trying to do is you're trying to aim as though you're aiming over here. You're aiming as though it's off the table. Does that make sense? And ideally, if there wasn't a bumper, the ball would just keep traveling in a straight line for forever. That makes sense? However, because there's the bumper right here, rather than going like into the negative values, see, imagine these are positive, these are negatives, at this point right here, it reflects and comes back the other way. And so in a way, when I'm trying to shoot a pool ball shot, I'm kind of trying to do an absolute value function in my head where I'm trying to think, okay, I need to aim for the closet door over there, knowing that if I aim for the closet door, it'll bounce here and come back the way I want it to. Does that make sense? In physics, anything that we do in reflections involves absolute values. So when we do like a mirrors unit on optics, it involves reflections. Here's kind of the same concept again, right? You guys can see how it's got this kind of bounce V pattern to it. Hey.
Do you have a stats calculator? I've got a real hasn't gotten yet.
Can you guys see the applications though? You can see how this can be useful somewhere, hopefully. So anyways, here's the point then. I need you guys to be able to graph this just like any other function and tell me all the properties of it. Okay. The most defining property of absolute value graphs is that they are never in the negatives. Right? They should always be above 0. So absolute value graphs also have a leading coefficient though. If I were to put a 2 in front of an absolute value graph, it just makes it steeper, that's all. In theory, I can actually make the absolute value graph always negative. If I were to give you -2 absolute value of x, what would happen is, rather than it always being positive, it would always be negative because it's now been flipped upside down. In the same way that a quadratic can be flipped upside down, you can flip an absolute value graph upside down. This means always make it positive. This then means, okay, always make it negative. Okay, so let's try that one right now. That's the next graph I have on here. Let's graph this thing and let's talk about all of the values that we want to calculate. So here's basically our graph, something roughly like this. What are some of the properties I normally ask you guys about when we're graphing things? Okay, let's start with that y-intercept. Is there a y-intercept on this? Yeah, doesn't it go right to the origin here?
If anyone has found a pair of glasses with a broken arm, can you please bring them to the office? A pair of black glasses with a broken arm, please bring them to the office.
Isn't the x-intercept and the y-intercept the same thing on this graph? Okay, what about domain? It is, yeah, x is on to the reals. Because you can still plug in every single value for x that you would ever want to. But, what about your range? On this one here, because I flipped it upside down, it's like a quadratic. Now, this is not known as a vertex. It's still a turning point though, right? Isn't this still where the graph turns around and goes the other way? So, y is going to be less than or equal to 0. It can be 0, but like this is as high as the graph gets. We could find a turning point. It would be at 0, 0 on this one, because essentially it's like the vertex, right? We could even do end behavior. We're going from quadrant 3 to quadrant 4. That makes sense? One last thing we can do is we can actually take an absolute value of another function. Like for example, right here I'm doing the absolute value of x plus 2. I asked for us to do a table of values, but I think let's just do a graph. And the graphs are actually on the next slides here. I don't know why I said do a table of values. Can you guys just look at these graphs right here? This is what x plus 2 would have been. And this is what x squared, oh no, it isn't. Never mind, skip that. Well, let's just draw the graphs here. X plus 2 would have looked something like that. And x squared minus 4 would have looked something like this. Okay. Now I'm going to absolute value them. Here's how you do that. It's really easy. See how this portion of the graph right here was above the x-axis? Keep it the same. See how this portion of the graph here was negative? Reflected. Just like my pool bank shot. Does that make sense? This is what the graph of the absolute value of x plus 2 looks like. It would have been x plus 2, except all this negative stuff right here gets made positive. Let me try this one here with you. I'm going to go the absolute value of x squared minus 4. Let me graph it for you. We'll show you what it looks like. It's kind of like part of the Batman symbol almost. Why does it look like this? Well, this portion of the graph was positive. Keep it the same. This portion of the graph was positive. Keep it the same. But you know, this portion of the graph right here was negative. All that happens is all of those negative numbers now flipped up and became positive numbers. That's all. If I had to summarize our lesson, I need you guys to be able to do 3 things. Thing number 1, do you understand the basic concept of absolute value and can you solve an equation? Okay. Equation solving with absolute value isn't harder, you just have to do double the work. You always have to check your work. That's all. It's not harder, but it sucks. 2, do you know what an absolute graph looks like and its properties? And basically it looks like a V. 3, if I give you a pre-existing graph, can you tell me what it looks like after you absolute value it? All you gotta do is take the negative stuff and flip it upside down. That makes sense? So let's try this one here. Here's the graphs. They're actually the same graphs as we had before. What would they look like if you absolute valued them? This section here would stay the same. And then this section here would reflect. Or on this one here, this section here would stay the same. And this section here would reflect. Let me make a harder one because those are way too easy. What if I gave you this graph here? Well, don't draw this out, just watch. This section here would stay the same because it's already positive. This section here would stay the same because it's already positive. I'm going to cheat because I can. This section here was negative. This section here was negative. This section here was negative. Take this and put it like that. And reflect it. Take this and put it like that. And take this, put it like that. Does that make sense? Long story short, absolute value is like the easiest function in the world. Basically, the rules are, if it's negative, make it positive. But how are you making it positive? By adding an extra negative. Here's a picture showing you kind of what I've been doing. What else do I got? Do you guys feel like you have the hang of it? Do you want to do these last examples?
No.
You're good? Okay. What am I call it then? Okay, 3 things. 1, can you solve algebra equations using absolute value? 2, do you know the properties of these graphs? 3, can you absolute value a graph? If you can handle that, that's the concept. So. Okay, I'll call it a day. You guys can have the last 25 minutes to work on whatever.